Now we're going to start looking at some of the shapes or geometries of these molecules. And I have this table for you. There's also a bigger table in your PowerPoint, but for the experiment, you're just going to need these. And that's because all of the molecules you're doing will have 4 electron groups, which I'll show you that part in a minute. But so these are the 4 geometries all of your ones in the lab will have for their molecular geometry. So let's do some drawing. Let me draw something right here to kind of tell you what this base shape is. So this base shape is called a tetrahedron, and that's like a geometric shape with 4 sides. But when you draw it for a molecule, it looks something like this. It has a central atom, it has 1 straight up, and then it has 3 that kind of come down in a triangle. And I'm not the best artist, but these 3 make an equilateral triangle, and they're sitting on the ground. And this is kind of in the middle, and this one, of course, is straight up. So that's the base shape that's a tetrahedron. Sometimes it's drawn like this. Let's see. Where when it's drawn like this, the solid lines mean those are on the screen, and this fat one is pointed out at you, and this dotted one is pointing behind the screen. So again, these 3 are flat on the ground. But anyway, whichever way you can see it. Also, there's an animation that's in our lesson folder where you can kind of play with the shapes and see them and stuff. I'm going to divide this up so that we know it's going to get kind of crowded, so that we kind of know what goes with what. Okay, and let's start here. We're going to look at some Lewis dot structures, and I'm just making up some molecules and assign geometries to them. Okay, so first thing we do is we count electron groups, and an electron group is a lone pair of electrons or a bond, and the bond can be single or double. On the lab assignment, all the bonds are single, but it doesn't matter which type of bond. So what we do is we look at the central atom, and we're going to count the lone pairs or bonds around it. And by the way, I didn't put all of these lone pairs out here if they're there, because they don't matter for the geometry. So we're focused on the central atom, and it has 4 bonds. So I'm circling these are the electron groups. There are 4. And the electron geometry is tetrahedral. And the molecular geometry is also tetrahedral. Let me draw real quick. So this is our shape that we just drew, where there is an atom on each one of those corners, and then of course the A is right there in the middle. Okay, that one doesn't seem that remarkable, and we'll make more sense out of these types of geometry when we start looking at some others. Let's go to this one. So let's do actually, let's make that top one a lone pair. Okay, so let's count electron groups. We have 1, 2, 3, 4. Lone pair counts as a group, so we still have 4 groups. So the electron geometry is still tetrahedral. I'm going to abbreviate that. but let's draw it. So we have our central atom, and then we have our triangle and the one going up. And what's different here is that we don't have atoms in all the positions. We have a lone pair. So I'm going to put 2 dots up there for the lone pair. And these are my bees going around. So now when I look at the molecular geometry, here's the key. Molecular geometry is looking only at the atoms. So electron geometry looks at all of the electron groups, and their shape, their geometry is a tetrahedron. But when I look at the molecular geometry, atoms only, then I'm looking at just these parts. And that makes a different shape. It could be like a little tetrahedron, like a short one, but we don't use that for the name. We call that shape, this shape that's left, trigonal pyramidal. And but anyway, so it's a different shape. So this is a case where the electron geometry and the molecular geometry aren't the same, and that will always happen if you have lone pairs, that they will be different. Let's try another one. Don't worry, I switched my A's and B's, it doesn't matter. Okay, this one still has 4 electron groups, so its electron geometry is still tetrahedral. Okay, let's draw it. So we start, the electrons are still tetrahedral, so we start the same way. So here's our central atom, but this one only has 2 atoms on it, so I'll put them there and there, and it has 2 lone pairs here and here. So now when we look at the molecular geometry, again, the electrons are tetrahedral, but molecular geometry, we're only looking at the atoms, and we call this shape bent. And we also say the angle here is 109.5 degrees. And the reason that I give the angle is that there's another shape that's called bent that we're not going to see on lab, and it's 120 degrees, so I distinguish the two. Okay, so another one where these 2 geometries are not the same. So the key is these are the same if there's no lone pairs around the central atom. Okay, let's do one more, and this one's almost kind of silly. I won't even do the whole thing. When you have 2 atoms, the molecular geometry is always linear, because the molecular geometry you're looking at, I got my wrong color there. It's not the color I wanted, but you're looking at just the 2 atoms, and they are linear. That's, oops, it's gone now. So anyway, anytime you have 2 atoms, it's just linear. And for those, I would say you can just like ignore those, or just say Na on those, because which atom would be the central atom anyway? It would be hard to say. So on those, just say linear for the shape.